So let's move on to the next question. We want to find out here how we can use the relationship marginal cost equals to marginal revenue to find out the solution that we got in part B, which was to find the profit maximizing level of output. If you recall, the profit maximizing level of output required us to get the first differentiation of your total profit function, which is also referred to as marginal profit, and we solved for X. So if you want to refer back to the second video for that, in this case, marginal cost equals to marginal revenue is an economic concept that also identifies the level of output that maximizes profit. So all we're doing here is going through a solution to get the same answer. If you recall, it was 3.58. So M-more in this case is your marginal revenue, MC your marginal cost. Both of these are your first differences of total revenue and total cost. So if you see in your question marginal revenue or marginal cost, you just get the first differences of the total revenue and total cost function. So recalling our total revenue function, not given in the question, but we derived this in part 1 or part A, the first video. So refer back to the first video if you're unsure where I got this. Deriving that marginal revenue is dy dx or dt or dx. 50x becomes 50, drop your x, minus 5x squared becomes minus 10x. In other words, your power of 2 multiplied by minus 5 will give you a minus 10, and you reduce your power by 1. So 2 minus 1 will give you a power of 1. So minus 10x to the power of 1 or minus 10x. We do the same for your total cost. We need to get the first differentiation of your total cost function. Again, refer to the first video in which I show you how to get this total cost function. And the first difference of that is because there's no x associated with the 40, that drops from the equation. We can't differentiate it with respect to x. The 7x, again, that x disappears and you're left with your 7. And your x squared becomes 2x. In other words, because the way the x squared is written, it's also written as a 1x squared. So you multiply your power by the number in front of your x. 2 by 1 will give you your 2. And you reduce your power by 1. 2 minus 1 will give you to the power of 1. Hence we have 2x to the power of 1 or 2x. And the relationship requires us to put marginal revenue equals to marginal cost, or marginal cost equal to marginal revenue. So we set that up like so. And we start tidying up the relationship there. So we'll have x's on one side, whole numbers on the other. So minus 10x minus 2x will give you your minus 12x, and your 7 minus 50 will give you your minus 43. And we end up with a minus 43 divided by minus 12, giving us an optimal value or a level of output that maximizes profit being equal to 3.58. And again, if you refer to the second video, we get the identical answer.